Susie knows it'll be hot inside her car, so before she starts her car, she rolls down her windows to let the car air out. Then she after starting the car and turning on her air conditioner, Susie can feel the temperature in her car gradually start to drop. So here's an equation that can model the situation. Okay, M is going to be the number of minutes since Susie turned on her air conditioner, and T is going to be the temperature inside the car in degrees Fahrenheit. So what was the temperature inside Susie's car at the exact moment she turned on her air conditioner, or when M equals 0? Well, it also says tell 2 different ways to get the answer. Mostly, to most of you guys, the obvious way to get the answer is to take 0 and plug it in for M into the equation. Oops, minus 0 plus 1. So 0 plus 1 is 1, square root of 1 is 1, 8 times 1. Gentlemen, please exit the room and go to the hall. Now, both of you. 104 minus 8 is 96. 96 degrees. Correct? Okay. Now, how important is it for us to notate what kind of degrees we're talking about? We are in America. Okay, I get that. Everywhere else is Celsius. I know we are doing a worksheet that very clearly says we're talking about Fahrenheit, but does it really hurt to make sure that we know we're talking about Fahrenheit? It really doesn't. Yes, you may. You may write 96 degrees Fahrenheit. Both of those are acceptable. Okay? So what's the other way we can figure this out? So in a complete sentence, right? Put the equation, if I can spell equation right. This is a scratch out, it's not equation. Into F1 and look at the table for x equals 0. Okay? What was the temperature inside Susie's car 3 minutes after she turned on her air conditioner? 2 ways? So look at the table, because we already have the equation in, right? So look at the table. At where? X equals 3. Or we could put it into the equation, right? So T equals 104 minus 8 times the square root of 3 plus 1. 3 plus 1 is 4. Square root of 4 is 2. 8 times 2 is 16. 104 minus 16? 88. Correct? Any questions so far? What was the temperature in Susie's car 1 minute before she turned on her air conditioner? How are you going to figure that out? Whoa, whoa, whoa. You're telling me there's such thing as negative time? You're saying negative 1 and for T? There's no such thing as negative time. You guys are ridiculous. So in this situation, we must use a negative number for time, right? Do we really have negative time? No. As far as notation purposes, we have to use a negative number to notate 1 minute before, right? Is there any other situation where we would use a negative number for something that we think that might be wrong? Like distance? Do we have negative distance? We can't, right? But we can have distance behind or below. Does that make sense? And we might be in a situation where we'd have to use something like a negative number for distance in a situation like that. Okay? So, negative 1. Oh, sorry. T equals, the temperature equals 104 minus 8 times the square root of what? Negative 1 plus 1? So negative 1 plus 1 is 0. Square root of 0 is times 8. 104 minus 0. So temperature is 104 degrees Fahrenheit. What's the other way to get the answer? Look at the table. At x equals negative 1. So what about 4? Susie will not feel comfortable in her car until the temperature reaches 84 degrees Fahrenheit. For what values of M is the temperature at or below this level? What goes where? Oh, 84 goes for T? Because that's the temperature, right? So 84 equals 104 minus 8 times M plus 1. Square root of M plus 1. How do I solve that equation? Subtract 104. I know. What's 84 minus 104? So negative 20 equals negative 8 times the root of M plus 1. Why did I subtract 104 from both sides instead of subtracting 84 from both sides? Because I have to isolate the radical. Okay? Now I divide by negative 8. What is negative 20 divided by negative 8? Negative 2.5. Oh, positive 2.5 equals the root of M plus 1. Square both sides. Good. 2.5 squared is 6. Did you know that? Yeah. Good. Because 2.5 squared is just going to be same as 25 squared with some with a decimal, right? Just got to know the place value issue. Subtract 1 to solve for M. So M equals 6.25. I mean 5.25. Except that's not what the question asked. What did the question ask? So is this an equation at all? What is it? It's an inequality. Very good. So how are we going to restate our answer? Can we use all the same work? Yeah, we can. Greater than or less than? Greater than. Greater than or equal to 5.25. Okay. Do we need to talk about the two ways to do this? I mean, it doesn't say it, but are we good? Okay. However, if the temperature goes below 78 degrees Fahrenheit, she's too cold. So she's a high maintenance girlfriend. Boys, avoid those. Girls, make sure you're not one.
She owns a lot of cats.
She probably does own a lot of cats, yes. Okay. If the temperature, so how are we going to set this up? 78, 104 minus 8, square root of M plus 1. So subtract 104. 78 minus 104. Negative 26 equals negative 8 root M plus 1. Divide by negative 8. Negative 26 divided by negative 8 is? Yes, sir? I will slow down for just a moment. Hold on. People are behind. I don't want to lose anybody. I'm not waiting for an answer. I'm just waiting for people to catch up. But thank you for offering. Are we good? Okay. For those of you who are caught up with me, see if you can answer number 6. We good? We good? Okay. So what is negative 26 divided by negative 8? 3.25 equals the square root of m plus 1. So if I square root both sides, or excuse me, if I square both sides, I get 10.5625 equals m plus 1. Subtract 1. So m equals, why do I keep doing that? 5625. I didn't even make room for myself to write the whole number. So what's the real answer? Less than or equal to that, right? So during what interval of time will she be comfortable in the car? M is, how do we want to write this? Probably 5.25 is related to m how? So m is really greater than or equal to 5.25, right? And less than or equal to 9.5625. Now we are talking about temperatures here, right? Realistically, we're talking about temperatures. We're going to measure 9.5625. Probably not. Probably be like maybe 9.6. But we're going to go ahead and write what we have so far. Okay. Now how many minutes is this? This is about, what is it about? I know it's about math, you smart aleck. About 4.3 minutes. Is that fair enough? Is that a fair statement? Okay. So here's the question we just did, right? Here's what it looks like on the graph. Here's what it looks like on the table. How do we find the intersection on a graph? Do you see what they put in? There's two equations in here, right? What's this equation right here? It's not, though. This is y equals 84. Okay? So this is our equation right up here. See, it tells you that right over here. Okay? Here's the graph, and here's 84. Why would we care about 84? That's where she's comfortable, right? Where she starts to be comfortable. What would happen if we found the intersection on the graph? What is this? How long it takes for her to get comfortable, right? Okay. How do you find the intersection? Do you remember how to do that? We go to menu, right? And it's under analyze graph. Okay. So menu, analyze. How does this graph tell you the solution to the inequality? When is this graph below 84? I need directional words. Izquierda, derecha. I'm not stupid. Is it to the left of this intersection or to the right of this intersection that the graph is physically below 84? It's to the right, right? So it's greater than that part. Does that make sense? Okay, it's greater than this point that the graph is below 84. So this is a visual way for you to be able to tell, because some of you had a hard time telling me if this was greater than or less than to begin with, right? You had to think about it for a second. So if you need that visual representation, look at the graph. Here is our original equation, and here's that 84. Okay? look at the point where they intersect. Where's the graph below 84? Well, it's to the right of that point. So it's greater than 5.25. Does that make sense? Okay. So what about the table? How do you make your table look like this? How do you make your table count like this? I want you to look specifically at that question right there for your homework. Okay? I want you to do some, not right now, not right now. I want you to do some exploring and figure out how to get your table to count by something other than ones. Okay? What about algebraically? We have to find the domain of the function. Okay? We have to find the domain of the function. How do we find the domain of this function? Without just like looking at the graph. Is there anything that m is not allowed to be? It can't be anything below 0, can it? Because that takes us into imaginary numbers, and while we're talking about quadratics, we can deal with that, but this is a real life situation. We're not going to deal with imaginary numbers in real life situations, are we? So I need what is under the radical, this x plus 1, to be greater than or equal to 0. Does that make sense to you? So if I subtract 1 from both sides, x has to be greater than or equal to negative 1. Has to be. Did we talk about something with negative 1 as an x value? What was it? The time before, right? And what was it? It was 1:04, right? The time when we said 1 minute before she turned on her air conditioner. So what do we know about that? Is that when she started recording the temperature? Would that be logical? That's when she started recording the temperature? Okay? All right. So solve the inequality by isolating radicals, squaring both sides. Okay? We did that already on the front. We don't need to do it again. We did that right here on this one. Sorry, on number 4. Okay? You can copy your work if you want to, but like number 4. We did on number 4. Okay? So if we're doing sample problems, what about A? If we square both sides, we get 3x plus 5 is greater than or equal to 16. Subtract 5, 3x is greater than or equal to 11. X is greater than or equal to 3 2/3 or 3 2/3, right? Okay. But guys, that's not the only answer. What else must I do? I have to find my domain. So whatever is inside of this radical right here, 3x plus 5, I also have to make greater than or equal to 0. Minus 5, 3x is greater than or equal to negative 5. Divided by 3, x is greater than or equal to negative 5/3. So look at it on a number line for me real quick. Here's negative 5/3. Here's 0. Here's 3 2/3. What's allowed to be the answer is everything from here, colored in, that way. Okay? What turned out to be the answer was everything from here, that way. Does this fit into the given answers? Then that right there is my answer. Okay? I will finish B and C on this video so that you will have these two samples right here. I expect these 6 done by the time you get to class tomorrow. Any questions? Okay, have a wonderful day. So, letter B. Subtract 7 from both sides. The square root of negative 4x plus 15 is greater than 3. If I square both sides, squared, negative 4x plus 15 is greater than 9. If I subtract 15 from both sides, I get 4x is greater than... Yes. Sorry. 9 minus 15 is negative 6. If I divide 4 by on both sides, I get 4 is greater than negative 3 halves. Oops. Guys, I missed the negative sign pulling it down here, so when I divide both sides by negative 4, I get 3 halves. Okay? So on my number line, I know it has to be, here's 0, here's 1.5, so 3 halves. I know it's here, that way. I also have to take what's inside of my radical and set that greater than or equal to 0. So negative 4x plus 15 is greater than or equal to 0. If I subtract 15 from both sides here, I get negative 4x is greater than or equal to negative 15. When I divide both sides by negative 4, I get x is greater than or equal to 3.75. Okay? Please don't forget that when you divide or multiply by a negative number, you have to flip the sign, so this is actually less than or equal to. That still doesn't make any sense. I'm sorry, guys. I'm trying to do this instruction and talk to a student at the same time, and I'm getting distracted. I apologize. I'm going to get out a piece of paper, and I'm going to do this one again for you so that I'm not distracted by my messy work. Okay? Here we go. Piece of paper. 7 plus the square root of negative 4x plus 15. See, I missed that 7 when I redid the other part, so I apologize about that. Greater than 10. Okay, so subtracting 7 from both sides gives me the square root of negative 4x plus 15 is greater than 3. When I square both sides, why don't I put 14? When I square both sides, I get negative 4x plus 15 is greater than 9. If I subtract 15 from both sides, I get negative 4x is greater than negative 6. If I divide both sides by negative 4, I get x is less than 3 halves, or 1.5. Okay? X is less than 3 halves, or 1.5. See, that's what I missed a second ago when I divided by negative 4 and didn't flip the sign. Okay? So there's an example of how easy it is to mess up if you're not paying attention. Okay? So just be real careful about that. So on my number line, I have a 0 and I have 1.5. And what I think can be the answer is everything less than that. Okay, that's what I think can be the answer. I have to check my domain. I have to check what numbers are allowed to be part of my answer. And what I do there is I take my whatever in my radical, negative 4x plus 15, and set that greater than or equal to 0. Whatever's in my radical must be greater than or equal to 0. So I subtract 15 from both sides, and I get negative 4x is greater than or equal to negative 15. Divide both sides by negative 4, and I get x is less than or equal to 3.75. So it's allowed to be my answer, is everything from here that way. Now, is this value that I got for my answer allowable in my domain? It is, so that is my answer. Okay? Especially for you visual people, it'll help if you draw a graph, a number line. Okay, so that you can see this is what's allowed, and yes, this is in my allowable domain, so that is my answer. Okay, now you may be confused as to what I mean by allowable or allowed or anything like that, and I think that C will help make more sense of that. Okay, so x plus 5 is less than or equal to the square root of x plus 5 and then plus 6. So first of all, I have to isolate my radical, and I do that by subtracting 6 from both sides. So x minus 1 is going to be less than or equal to the root of x plus 5. Okay, when I square both sides, I get x squared minus 2x plus 1 is less than or equal to x plus 5. Okay, please remember that this is x minus 1 times x minus 1. Okay, it is a quadratic, so I do want to get it equal to 0. So I'm going to subtract 1x from both sides, and I'm subtract 5 from both sides. So what I end up with is x squared minus 3x minus 4 is less than or equal to 0. Okay, I can factor this to be x minus 4 and x plus 1 is less than or equal to 0. Excuse me. This gives me x equals 4 and x equals negative 1. Okay. Now all I did was set these equal to 0 real quick. That's why I have x equals 4. We'll come back in just a minute and check with the inequality sign. But first I do have to check both of these answers. Okay, so when I come back up here to the original problem, I have 4 plus 5, which is 9, is less than or equal to 4 plus 5 is 9, and the square root of 9 is 3, and 3 plus 6 is 9. 9 is less than or equal to 9, so math. Okay, when I substitute in negative 1, okay, I get negative 1 plus 5 is 4. Is less than or equal to negative 1 plus 5 is 4. The square root of 4 is 2. 2 plus 6 is 8. So that does not work. So first of all, this solution isn't even a possibility. Okay. Then I go back to my original problem, and I do have a less than. So x is less than or equal to 4. Okay. So on my number line, I have 0 and I have 4. Okay. So I know what I think is the answer is everything from here that way, less than or equal to 4. Okay, I do have to check my domain, so I take what I have in my radical and set that greater than or equal to 0. But look what happens when I do that. I get x is greater than or equal to negative 5. Okay, what's allowed to be in my domain, here's a negative 5. What's allowed to be is everything here to the right. But the answer I got was everything from 4 to the left. So this part right here, from here to here, is the only thing that's allowed to be as my answer. Okay? As far as solving the equation, every answer that's less than 4 is a solution to the inequality. However, because of the domain, anything less than negative 5 will give me a non-real answer. And so my actual answer is from negative 5 to 4. That is my final answer. Okay, we will talk about this tomorrow in class just very quickly if you have any questions. Otherwise, I will see you for tutorials after school on Monday or before school on Tuesday. Come ask me questions if you need to. Have a wonderful day.